Welcome back, everyone, to our Space Symposium. Next up, we have Mynaric. It trades on the NASDAQ under the symbol MYNA and on the Frankfurt Exchange under the symbol MOYN, and is leading the industrial revolution of laser communications by producing optical communications terminals for air, space, and mobile applications. Laser communication networks provide connectivity from the sky, allowing for ultra-high data rates and secure long-distance data transmission between moving objects for wireless, terrestrial, mobility, airborne, and space-based applications. The company is headquartered in Munich with additional locations in Los Angeles and Washington, D.C. Today, we'll be speaking with the co-CEO, Mustafa Veziroglu. Mustafa joined Mynaric in August of 2022 as president and was, until January 2023, responsible for development, qualification, and serial production of the company's laser communications products. Since February of 2023, he jointly leads the company with Bülent Altan as co-CEO. Prior to joining Mynaric, Mustafa served as the Chief Operating Officer for SA Photonics. Under his leadership at SA Photonics, the company successfully demonstrated space-to-space optical communications links in low Earth orbit in partnership with the Defense Advanced Research Projects Agency, DARPA, and the Space Development Agency, SDA, as part of the Mandrake II program. Prior to SA Photonics, Mustafa spent more than 10 years in leadership roles in the semiconductor industries at companies including Lattice Semiconductor and Xilinx. So Mustafa earned his electrical engineering degree from Massachusetts Institute of Technology and MBA degree from Santa Clara University. It's an honor to welcome you to our conference today, Mustafa. Welcome.
Thank you. Really appreciate it for a nice introduction for the company and for me. I really appreciate that. So with that, I think we would jump right in. So before I get into the details of that, unfortunately, I need to do a disclaimer. Just a reminder, I'll be making some forward-looking statements today, as well as discussion of non-IFRS numbers. I won't read this in detail, and if anybody is having sleeping issues, I urge you guys to look at it. It'll certainly put you to sleep probably, but it's a necessary requirement. So you can look at it at the disclaimer in the regulatory filings for all the risks related to these statements. So with that, I wanted to briefly reiterate again what we do. I think we talked just a little bit at the introduction. Mynaric produces laser communication equipment for all domains, initially focused on space and airborne, but also focused on terrestrial, maritime, and mobility. So fundamentally serve these communication markets for a whole slew of both defense companies and primes, as well as commercial partners. As you can see here, here's a subset of a set of customers that we engage with. The largest of our closest cooperation right now has been with Northrop Grumman, and we've had mutually a number of big successes already. Now, why we exist? Essentially, our vision really is eliminating barriers of connectivity. There are a lot of barriers out there right now, either geographically or otherwise. Our vision is to provide an alternative to radio frequency, RF connectivity, and we use lasers to accomplish that. Our primary markets are both government and commercial segments. In terms of our scale, in terms of our strategy, it really is, we are taking the laser communication from what I consider an experimental one-off, exquisite type of communication terminals to a mass serially produced, affordable, reliable form of communication technology that would coexist along with the radio frequency And we would also provide standardization capability so that these terminals can interoperate not just between our terminals, but with terminals from our competitors. We believe that by standardizing the connectivity and communication, the whole market will grow substantially as opposed to having patchwork of individually non-standardized communication. Our global footprint is worldwide. This is, we have, as we talked about, headquartered in Munich. I am, while I'm an American and lived in California the bulk of my life, I have recently moved to Germany to be close to production and research and development. And I'm residing in Munich, but that's where our headquarters is. And we have a major facility in Los Angeles, Hawthorne, as well as close to the US government offices in Washington, DC. We have over 300 employees. More than half of those are qualified engineers. And we pride ourselves with having a broad spectrum of really 40 plus nationalities. So we have a good melting pot of great ideas from across the world, best talents from across the world coming to work for us and with us to really create the next level of connectivity. I am, as mentioned earlier, co-CEO and lead the company along with Bülent Altan, who's been the CEO up until recently. He and I work hand in hand very effectively. Currently, the way that we divide the labor task is obviously we help each other across the whole spectrum, but he focuses on external and big strategic vision related stuff, and I work on more closer to day-to-day execution and delivery. And part of this is necessitated by the stage of the company. We went from an idea of a company to actual large order with real need for manufacturing, scaling and delivering, and that's sort of how we are executing with the company going forward. Recently, you may have seen an announcement of the intent that Bülent will be moving on to the supervisory board pending shareholder elections, and will be continuing in the same role as a supervisory board member, while I'll be the sole CEO going forward after the General Assembly, I believe sometime in mid-summer. Before we go on to looking forward-looking stuff, obviously there's a problem to be had, and which is what we're providing a solution to. So today's connectivity utilizes radio frequency, as I mentioned, or through a hardwired fiber optic connection using lasers, but using hard connection terrestrially. This has a number of drawbacks. First of all, not every location can be connected through fiber. There are, whether it is in terms of a city block where there's so much congestion that you cannot add another fiber line, or you're in remote areas, whether it is US or international, where it just does not make sense to have a fiber optic connectivity. So the only other way to solve that, to deliver communication to the rest of the people, are through either satellite-based or some other form of radio frequency, and that has a number of limitations. So in terms of communication, I'm able to communicate to you directly because we are on a low latency terrestrial-based communication. But when you're looking at trying to deliver connectivity to the masses, the rural controlled areas, satellite-based solutions today are not the best of solution. From the time I communicate to when I receive your response in a communication, whether it's video or audio, the latency, essentially that transit time going from me to the satellite to come back to me, that is not very conducive to a productive communication. So we believe that the current way of solving through satellite and geo orbit really has these types of latency problems, as well as today, each of those satellites are multi-billion-dollar satellites with the communication devices on it. So the amount of bandwidth available is limited and not really conducive to commercial applications. So those are some of the limitations of today's connectivity. We believe that the future of connectivity will enhance the capabilities through radio frequency communication, as well as the terrestrial fiber optic communication, but complement that in a very meaningful way through laser communication. And laser communication has a whole slew of advantages. One might ask, why is it now the time? And really, the laser communication has been thought of being the next generation communication technology for quite some time. But the maturation of the technology has not been, I think the providers have not been able to mature the technology enough for broad scale deployment. And we believe that the innovative architectures that we've done with the idea of mass production as well as affordability sets the stage up for this market to be to actually reach its potential. So we believe that there will be a constellation of satellite-based and multi-layered satellites, whether it is low Earth orbit or mid-Earth orbit or geostationary orbit. There will be a combination of those. But in addition to that, we anticipate significant connectivity through the aviation, airborne, as well as mobile, on the move, or maritime, and as well as ground connectivity. So anything that's in space needs to connect to something on the ground. So we believe that this set of structure, as I share with you, is the future connectivity. It's always on and always connected. So why lasers as opposed to radio frequency? The laser communication enables very high data rates and link distances. So we're talking in terms of gigabits. Today, the SDA, Space Development Agency, is deploying in low Earth orbit 2.5 gig connectivity for lasers. But that same technology we can actually communicate in 10 gigs today. And we have demonstrated in the lab 100 gig as well as 10 times that bandwidth in the early research lab. So we believe that this technology is able to scale in terms of data rates as well as distances. So each of these connectivity in space is not from one telephone pole to another with 100 meter or 100 yard, depending on geography, distances in connectivity, or a couple of kilometers. But for example, we're able to communicate in low Earth orbit anywhere from 4,500 to 6,500 kilometers. So these are very narrow beams, and obviously it comes with a pretty substantial amount of technical IP, and be able to do those in a cost-effective manner that's low cost, size, weight, and power. That's what differentiates from other things. So we believe that data rates as well as cost effectiveness for laser communication is going to be substantial advantages over radio frequency. The other part that's probably lesser known is that instead of getting a license for each of the connectivities for whatever the bandwidth is, the laser connections are all license free. There's a whole bunch of reasons for it, and we can discuss that later on. But because of that, the operators, network operators, or our customers don't need to spend a lot of money invested in securing licenses. So we think that that is license-free capability is a huge advantage. And then for certain applications, and for a lot of applications, but specifically for Defense Department applications, secure data transmission that's highly resistant to jamming or spoofing or interference is at the heart of why the U.S. government is right now deploying laser communication in space. So in the era of denied GPS and denied RF environment, the only way to communicate is laser communication. And we feel that we have a technology that's able to do that today. In terms of our product portfolio, we have two distinct products currently available. Condor, which is a bit more mature, it's actually, we are in the deployment stage of this, is our space-to-space and space-to-ground communication terminals. So these are space communication terminals that is going to be deployed in the Space Development Agency and potentially with the commercial constellations. So this Condor product portfolio, in particular Condor Mark III, is the product that we have with a significant backlog already from our key customers. Our second product portfolio is Hawk, and Hawk is developed initially for airborne application, but the same technology could be utilized for mobility, so in terms of Humvees or airborne, maritime, etc. So this is more on the move type of things where there's more rapid change in location, etc. And we believe that combination of Hawk and Condor sets us up for a whole bunch of really exciting market opportunity going forward. From an investment perspective, the highlights, as you can see, there are about 5 different aspects of why you should be excited about it and why I'm excited about it enough that I uprooted my family from California and went over to Munich to lead the company. We are on the cusp of a very, very significant growth in the market, and we can talk about this a little bit more in general later on. So overall, huge market potential, and we are at the cusp of that knee of highly exponential growth. The second part is that the U.S. government, in the era of near-peer countries like China, has a very strong desire to have unjammable and interceptable communication capabilities. So there's a very strong reason for the U.S. government to pursue this, and with the significant reduction in launch pricing, the whole network of being able to do internet in space is now going to be a reality. In addition to the government needs for the near-peer type of technology solution, there's also commercial programs as well. I think the most important of which is demonstrated by SpaceX, that there's large commercial constellations, and each one of those constellations needs to be connected at a very high bandwidth. So we believe that there is a significant commercial opportunities available for us. So, and given our product portfolio today, we feel that we're well positioned to take advantage of the government and commercial markets. And our track record and the announced significant design wins recently, we believe that we're really well positioned. But all that would be nothing if it wasn't for the differentiated technology that we have developed. So our technology and the investment that we made in production really allows us to produce these things in very high volume. And that's unmatched by any of our competitors. So we believe that we are well positioned with the investments we've made to be able to scale to real high volume, because we believe that the markets will demand that kind of high volume. And our technology, the IP, differentiates us in terms of leadership position in the market. So focusing on the space technology, which is where we have the most mature backlog and product, if you look at just even in the last few years, we're going from 2,000 satellites to 5,000 satellites, or even, I think as of today, probably about 7,000 satellites in space. And we anticipate that by the end of the decade, that could grow by another factor of 10 or more to 100,000 satellites. And each one of those at some point in its life is going to be needing connectivity, high bandwidth, license-free connectivity through laser communication. And just to give you the concept on satellites versus terminals, typically our current customer base in space needs anywhere from minimum of 2, on average 3 to 4 of our terminals per satellite. So if you think about that, all the orange stuff that is on commercial or communication constellations, each one of those satellites will need anywhere from 3 to 4 laser communication terminals. So you can see the scope of the market. But one other aspects of it that I think maybe not appreciated as much is that these satellites have a very limited lifetime. So usually the satellites have a 5-year mission. That means that every 5 years, whatever the constellation that you put up, whether it is government or commercial, needs to be replaced by another set of satellites. So from that perspective, not only do we have a market expansion of the satellites, but we also have replacement, built-in replacement. Every 5 years, every single satellite in low Earth orbit will be replaced. So just think about that. Big, huge growth market, and with a built-in replacement or built-in 5-year lifetime that allows us to be very successful in here. In terms of the talked about government and commercial programs, in the near term, we've seen the biggest acceptance in the broadband satellite communication, along with satellite intelligence. So, but if you look at where we think that these types of constellations and the types of applications, we see satellite broadband, satellite intelligence, data centers, civil and manned air, military, UAV. Each one of those we anticipate, and these are the players in this area, will anticipate that they will be utilizing and leveraging laser communication. This chart talks about our recent program wins. I think you may already have seen our press releases on various different successes. So I'll spend most time on Space Development Agency. Space Development Agency had a Tranche 0 constellation that was very small. They are in the process of doing Tranche 1. All the contracts have been awarded, and I'm happy to say that our market share in Space Development Agency's Tranche 1 constellations is actually very, very good. So that gives us the credibility when we say we have a product portfolio that is differentiated, and we have the investment in the manufacturing capability, because this is the kind of market where you cannot start building capabilities after you get the orders. So you have to invest first. And that's one of the differentiating capabilities that Bülent has put in place for Mynaric as a DNA. We anticipate the opportunities, we invest in advance. That allows us, in addition to our technology differentiation, allows us to actually give the confidence to our customers that we'll be able to meet their needs. Last thing, a company who's investing $2-3 billion for their constellation want to worry about is, will these guys that I'm counting on for laser communication be able to deliver to me the kinds of quantity I need? And the answer, obviously, for us is yes, we can. And if any one of you is interested, we can provide you with the capabilities that's in place today. In terms of differentiated technology, one of the strategies that we have done from a product perspective is, how do we deliver a differentiated technology that is scalable, affordable, and easy to manufacture? So every single decision that we make or we have made really is towards that goal. Lower the cost, increase the manufacturing efficiency and simplicity of the design so that it doesn't take 10 engineers to put this thing together and calibrate it. An example of that is our terminal, our telescope, which is the biggest. Think of it as a telescope, and then there's an electronic component that controls the telescope. So telescope is at the heart of this technology, and we have an all-metal design that is vertically integrated at our facility in Munich that allows us to be able to significantly reduce the cost and improve predictability and reliability of the product. So again, differentiated technology geared for high volume, low cost, highly reliable, scalable solution. Here's an example of on the unit cost. So from our Condor Mark 1 to Condor Mark 3, we've already seen a 5x reduction in costs. And we anticipate that to continue because it's in our DNA as we scale up, to continue to reduce both the material as well as integration and hands-on touch labor cost. And we think we're in a very good position for that. Here's our facility that exists today, and we're able to, with the technology and the capability invested as we today, we have the capacity in place to be able to produce as many as 2,000 units per year. Now, qualified, that doesn't mean that we have all the people necessary. That would not be the best thing for us to do. We will hire people to support this technology as we see the demand effectively solidify. But with lead times still, as of today, still in the neighborhood of 9 months to 12 months, we need to have the production capital expenses already ordered and in place to be able to support the future demand. And here's an example of all the things in place. Okay, now let's switch gears to the financial performance. In terms of the metrics that we look at, we're still what I would consider a early part of a high volume production company. So from what we're looking for is not revenue at this point, but more the backlog. And these backlogs are firm backlogs with customer and customer commitments. So there's the terminal backlog we look at, and we also look at cash in from customers. In other words, as we have firm contracts in place with firm backlog, the customers start giving us cash to support the development milestones. Unfortunately, given the financial reporting requirements in Europe, we're not able to recognize those as revenue. So that's why the revenue is lagging cash in. So let's look at our performance in the year 2022. We went from a cash in from customers from $3.9 million to $18 million for the calendar year 2022. Our firm backlog was 40 at the end of 2021. Our end of year 2022 firm backlog is 256. So you can see that we're beginning to see that knee in the curve going up exponentially. In terms of revenue, as I said, due to revenue recognition measures or rules and regulations, the revenue is lagging the customer cash in. So our revenue in 2022 was $4.4 million. That's significant in terms of percentage growth from 2.4, but nevertheless, it's still a fairly small number relative to the backlog and the cash in. So we anticipate this is really the lagging indicator for us. From a personnel cost, I think we're in a well position from a research and development point of view. So we don't anticipate necessarily our personnel cost to go substantially higher than these numbers, but we've gone from $23 million to $37 million from 2021 to 2022. In terms of outlook, as I said, the cash in is a leading indicator. So in 2022, the total cash in was $18.3 million. Year to date already is 18.8. From a terminal backlog point of view, the end of year 2022 was 256. Year to date, we are at 348 terminals. So again, very significant execution in terms of identifying and closing down on contracts. So in summary, again, why should you be excited? This is an amazing growth story. It's a fantastic growth potential in the market, differentiated technology that we have that allows us to be very strong competitively. And then we have very strong government and commercial market opportunities that's nearing. Effectively, I think government is in place. We're anticipating commercial markets to start adopting this in the very near future. And the DNA of the company is really to focus on serial production and be able to unlock these economies of scale for our customers and deliver them the technology they need to be able to install their constellations in place without worry of other concerns. So that really is a quick run through of my presentation. And I think at this point, we're probably ready for any kind of Q&A that you might have.
Great presentation, Mustafa. Thank you so much. If you will, go into a bit more detail on the space opportunity. You mentioned 100,000 satellites by the end of the decade. So markets are expecting significant growth, but it doesn't seem to be a winner-take-all market, right? So from your perspective, what are the key differentiating factors that you believe will determine success? And how specifically does your product enable that success?
Yeah, so a couple of things. Let's divide our product from our customers' product. So our customers would be the constellation providers, and each one of those constellations will have their own specific market needs. So it won't be a winner-take-all from a constellation perspective, because likelihood is each one is going to be focusing on different aspects of it, whether that is low latency communication or very high bandwidth without regards to latency, whether that's reliability, whether that's, there's a whole bunch of things that will be differentiated. And also, it also depends on how well they will be integrating and how they see the terrestrial part of the solution and airborne part of the solution. So it will be a multi-purpose set of constellations. But what's common across all those is the need for highly reliable, affordable, high volume, producible technology that the network operators don't need to worry about. And that's, I think, what differentiates us from our competitors. So we believe that commonality, our product portfolio, standardized product portfolio, could meet the needs of most of these customers. And our roadmap allows us to satisfy even the most demanding customer, commercially or defense.
Thank you for that answer. Let's talk more about the products. It seems you're really focused on building standard products that you can sell to many customers, as opposed to selling highly customized solutions for individual customers. So what really drove that decision, and how does that help you scale the company and generate better fundamentals?
Yeah. So, there are a number of examples you can do. So if you're doing highly specific product for a customer, the only way you're going to raise revenue is by hiring more people, because each one of those efforts are research and development heavy. So my revenue potential growth is going to be highly dependent on my ability to scale number of people and engineers. And that's not a model that we chose for our company. What we chose for our company is understanding the market needs with a opportunity in the market where the maturation of the technology allows us to be able to deliver high volumes of terminals. And the only way you can produce high volume is to standardize. And that's why we're going after. And once you have standard products, your scaling of revenue is not dependent on how many people you hire. So as you build more of the technology that you do, the more of the product, your margin expands. Essentially, each additional unit you book on a standard product will drop more of their profit, gross margin, into a net operating margin. So that's, we were looking for scalable business model, and we think this is the way to scale and deliver, very good returns, as opposed to my returns is a fixed percent of my revenue that is highly dependent on how many engineers that I have on my staff.
So much of the growth in unit volumes for satellites, Mustafa, by the end of the decade will be in LEO, low Earth orbit. So does it seem that LEO could get a bit crowded, a little traffic up there? And how do you think all constellation operators are looking to mitigate this issue?
Yeah, I think two aspects of it. One is, I'm going to sound maybe a little bit of cliche, but space is huge. Right, so these are small satellites, and it certainly can accommodate a lot of. So space is not the issue. What is unfortunately going to be an issue is, and which is why our technology is an advantage, is that if each one of these terminals, each one of these satellites have to rely on communication through radio frequency, that kind of licensing, the availability of licensable spectrum in low Earth orbit without stepping on your neighbor's spectrum is going to be very, very difficult. So for an RF, that will be a very highly congested environment. However, because of the very narrow beams of the technology we have with laser communication, that concern is not valid. So from our perspective, space is huge. Satellites can coexist in large volumes, but the licensing of RF would be harder. Therefore, the necessity of utilizing laser communication technology would be fundamental to any large constellation.
That makes sense. We have a question from the audience. So as you look out over the next few years, is there one product or other that you believe will really drive growth, meaning space or airborne? And what is the gaining factor on end market growth for the other products that may not grow as fast as the other?
Yeah, so I think this is, think of this as the early part of communication infrastructure. So I mean, I'm probably older than most people on the audience right now, but I distinctly remember a telephone coming into our neighborhood, happened to be at our house because the prior resident was a doctor, and there was one telephone there, right? So the issue here is essentially what we anticipate is the need for communication will grow, and as the leading market of that is space technology and space constellations, and as the space constellations get in place, everybody else is going to want to connect to the space, whether that is from a Humvee or whether from a car, whether from a ship. So as the constellation space-based fundamentals are in place, everybody else is going to want to connect to it. Just like in the original, communication one. It was a very niche market. Once the need, the benefits of the communication technology was proven by early adopters, there was a network effect of the more people that are plugging in, the more value each one gets. We believe that the Space Development Agency, their drive to create this constellation in space is going to be that proof point of time is now. Let's develop the commercial constellations in space. And once we do that, the next one will be airborne and terrestrial. So that's how I see in terms of biggest short-term opportunity, space. But once that is in place, the airborne and other ones should follow through.
Yes, great reference. Who knew the telephone would transform humanity like it has? So space is not next, it's here. So it also seems like this is both a technology play as well as a scale play. So you talked about having capacity to build 2,000 units, but it seems the industry will need a lot more than that by the end of the decade if the constellation numbers are even close to what is forecasted. So how do you think about your future capacity needs? Any major investments? And talk about your competition.
Right. So I think, remember what I said earlier, right? It's invest first. That's our DNA. That's what we do. We believe that what we have invested so far in terms of 2,000 units per year is a bit ahead of our current capacity needs, but nevertheless, it's something that gives the confidence of our customers to say, I'm willing to commit my large constellation of thousands of satellites to a customer because Mynaric already has the capacity to build 2,000 units. Now, as we go and identify and as the markets drive the needs for that getting to 10,000 or 20,000, we will be able to have at that point time to be able to react. So we are now backlog of 350. We have a capacity of 2,000. When we have a backlog of 2,000, we should have a capacity equivalently higher, 10,000 units. So because we are ahead of the curve, as we substantiate the demand, we will expand the capability. But don't think of it as now we're going to have, if the capacity goes up by 5x, now we're going to need 5x more capital. Think of it as we are always looking to be able to produce more in terms of going down the learning curve, simplifying the solution, so integrating the solution. So we're also going to continue to deliver more with the same amount of footprint and the capacity of the capital equipment. So there are a number of things we're doing from product enhancements that will allow us to increase the unit capacity. At the same time, we will invest in additional capacity as the need is substantiated.
And last question, only due to time, can you go into a little bit more detail on the competitive environment? And let's close with what are the key factors that you believe will help you win?
Right. I think, again, confidence. I mean, at the end of the day, our customers, we are, as expensive as our terminals are, we are a very small part from their cost structure. Yet the technology that we deliver to them is enabling technology, right? So from a perspective of what the customer gets in terms of value versus the cost that they incur, there's a huge amount of mismatch there. So what differentiates us is that ability and the confidence that our small part of the cost for them will not prevent them to be able to launch their constellation. So again, scalability, confidence to deliver. Those are differentiating points. The second part is obviously the cost and reliability, right? So that there's a lot of things that go into that. Manufacturing obviously is one of them, but we believe that our fundamental technology of all metal telescope and similar technologies of vertically integrated capabilities sets us apart from our competitors. So the bottom line, we believe we have a better technology that's scalable, lower cost, and we've made the investment to be able to produce and give that peace of mind to our customers. And if T1 SDA Tranche 1 market share is any indication, our customers believe in the solution that we're providing.
Wonderful, wonderful presentation. Fascinating topic here. Thank you so much for joining us. We would love to have you back on our conference in the near future with some updates.
Thank you. And if I may ask one thing of you, so for our customer or for our investors, if you'd like to be included in the Mynaric's investor alerts, please email us your connection or contact information to investors@mynaric.com. And Mynaric is spelled on the chart at MYNARIC.com.
Yes, perfect.
Thank you so much.
Thank you, Mustafa. Okay, everyone, stay with us. We'll be right back with our next presenter.